Hello students, welcome to Academic Aura. Today we will begin with exercise 5 of the chapter number 5 GCD and LCM. Just a reminder children, if you have still not subscribed to my channel, please do subscribe and also like the video if you find it helpful. Now see the first sum. Choose the correct option. What is the smallest prime factor of the number 75? Okay, prime factor. Now we have factorized the sums. Like suppose, like see, if I'm just showing you, suppose 75. If you factorize 75, okay, last number is 5, so we cannot take 2. We can take 3. 3 2s are 6 in this. Carry 1. 3 5s are 15. Now 5 5s are 25, and then 5 1s are 5. Okay, so here 3 5 5. Okay, what you get is 3 5 5. So which is the smallest prime factor? You write all the primes. 3 into 5 into, I'm writing it here, 3 into 5 into 5. So which is the smallest one? Smallest one, which is the smallest prime, is 3. So here option B, that is 3, is the right answer. Understood the first one? Second one, what is the least common divisor of the number 17 and 18? Okay, least common divisor. Now least common divisor of 17 and 18 will be 1. Now see why it is 1? Because 17 and 18 are co-prime numbers. See this. Now see 17 and 18. Okay, if you factorize, can you factorize 17 and 18? Because 17 is a prime number. It doesn't go in any table in 1 and the number itself. So 1 17s are and 1 18s are. Okay, so 17 and 18 are co-prime numbers. That is why their common factor is only 1. Understood? So therefore, what is the least common divisor of the numbers 17 and 18 is 1. Now see the true or false. Every prime number has only 2 factors. Suppose a prime number 5. Which are the 2 factors, prime factors? 1 and the number itself. So same way, if I take 7, 7 1s are 7 and 7 itself. So every prime number has only 2 factors. That is true. Understood? Now the product of 2 prime numbers is always a prime number. True or false? Now see, product means multiply. Okay, product means what? Multiplication. Product is what? Multiplication. You multiply 2 prime numbers. Now I'm taking 2 prime numbers over here. 5 multiplied by 7. 5 and 7 both are prime numbers, right? If I'm taking 2 prime numbers, product means you have to multiply. 5 7s are 35. So what have they said? The product of 2 prime numbers is always a prime number. Is 35 a prime number? No, 35 is not a prime number. Okay, it is a composite number. Understood? It goes in 7 times table, it goes in 5 times table. So the product of 2 prime numbers is not a prime number. Okay, it is a composite number. So this statement will be false. Now see, this GCD is a divisor of the LCM. GCD is a divisor. Yes, GCD is always a divisor of the LCM. That is true. Then see, LCM is greater than the given numbers. LCM is greater than the given numbers or equal to the smallest number between those numbers. So again, this statement is also false. Okay, so here in this exercise 5, I have finished exercise question number 1 and 2 here in the textbook. Then now I'll be showing you question number 3. Now see the third question. Express the number as a product of prime factors. Okay, express the number as a product of prime factors. This we have already done in the practice set before. We have to only write the product of the prime factors. Suppose you take 91. Okay, now you factorize this number 91. You can take 7 times table over here because it is not going to go in 2. Last number is 1. It is not even going in 3. If you take 3 3s are 9. 1 is remaining. Okay, so you can take 7 times table. 7 1s are 7 in this. 7 1s are 7. How much is left in 9? If 7, 8, 9. 2 is left. So it becomes 21. 7 3s are 21. 13 is a prime number. It doesn't go in any table. Only 13 1s are 13. So what are the prime factors of 91? 7 and 13. 7 multiplied by 13. So these are the prime factors, product of their prime factors of 91. Now see 160. Again we will factorize 160. What is our last number? Is 0. That means we can take 2 times table. 2 8s are 16, 2 zeros are 0. Again 2 4s are 8, 2 zeros are 0. 2 2s are 4 and again 2 zeros are 0. 2 10s are 20. Then 2 5s are 10 and now 5 is a prime number. So 5 1s are 5. Understood? So now we will write the prime factors of 160. What are the prime factors? 1, 2, 3, 4, 5. 5 times 2 into 5. Okay, so these are the prime factors of 160. Now see the next one, that is 89. Okay, now 89 is a prime number which doesn't go in any table. Okay, it only goes in 89 ones are 89. Now see this, even if you do this factorization, it is not going to go in any table, only one in one table. 189s are 89. Now see, they have said product of prime factors. Prime 1 is not a prime factor nor a composite number, so we will only take 89. So therefore we have 89. So 89's prime factor is 89 only. Understood? 89's prime factor is only 89 because 1 is not a prime nor a composite number. That's why 89's prime factor will be 89 only. Understood? First, second, third of the question number 3. Okay. Now see the next fourth question. Now see in the fourth question you have to find the GCD. Okay. Now GCD, in my previous video I have already shown you how to do the GCD by 2 methods. That is the first method was writing all the factors, writing the factors of 21, 42, write all the factors and then you have to write the common factor. After writing the common factor you have to see which is the highest one. The highest will be your GCD. Okay, but I am doing the direct vertical method over here. So 21 and 42. See, if your teacher tells you do any method, I will tell you go for the vertical method only. This is easy. Okay. And also please do let me know how you find this video. Let me know in the comment section whether it is helpful, it is not helpful, it is good or it is bad. Whether you all understood the sums. If you all didn't understand, please let me know. Now see here, 21 and 42. Can we take 2? No. See, this is divisible by 2. This number 0, 2, 4, 6, 8 last, it is divisible. But here there is 1. That means it is not divisible. That means we will take 3 because both the numbers are divisible by 3. 3 7s are 21 and here 3 1s are 3 in 4. 1 is left, carry here 1. 3 4s are 12. Now 7 and 14 both are divisible in 7. 7 1s are 7. 7 2s are 14. Understood? Can you again take 2? 2 1s are 2. No, because this is GCD. When we are doing LCM, we can proceed. 2 1s are 2, we can take. Okay, but when we are doing GCD, we have to stop when it is not going. Okay, so we have to stop and we will just take these factors and multiply it. So therefore, what we get, 3 multiplied by 7 is equal to 3 7s are 21. Understood? 21. So therefore find the GCD of, you can also write here, therefore GCD of 21 and 42 is 21. Understood? Let's see the next one, 17 and 9. Now see 17 and 9. 17 is a prime number that doesn't go in any table. 9 will go in 3 times table, but we want a number in GCD that should go in both. But here it is not going in both. Any number that is going in both the numbers. Okay, it will only go in 1. 1 17s are and 1 9s are. 1 17s are and 1 9s are. Understood? So therefore what we get over here, 1 GCD is 1. So therefore you got 1 as the GCD. Okay, that is the highest factor is 1. So therefore you can write, therefore GCD of 17 and 19 is 1. You can also mention here that as 17 is a prime number. Understood? 17 is a prime number. Whenever you have one prime number, that means you cannot proceed. Okay, you have to stop the division and it will go only in one times table. 1. Okay, so that's why the highest common factor is 1 and 1 is only the GCD over here. Understood? So GCD of two numbers is 1 over here because 17 is a prime number. Now see the next one. 120, 180 and 240. Now see the last number is 0. So we can first begin with 2. 2 6s are 12, 2 0s are, 2 9s are 18 and 2 0s are. 2 1s are 2, 2 2s are 4 and 0 over here again. Again our last number is 0. Again we can take 2. 2 3s are 6, 0. 2 4s are 8 in this. 2 4s are 8. In 9 we have 8. 1 is remaining. Carry here. It becomes 10. 2 5s are 10. 2 6s are 12 and this 0. Now see, can we take 2 again? No. These two 30 and 60 are divisible by 2, but 45 is not divisible by 2 because the last number is 5. But we can take 3. Okay. 3 10s are 30. 3 1s are 3 in this. Okay. If 3 1s are 3, carry 1. 3 5s are 15. 3 2s are 6 and this 0. Now see here 10, 15 and 20. 10, 15, 20. All three are divisible by 5. We can take 5. 5 2s are 10. 5 3s are 15 and 5 4s are 20. Now what happens? We have to stop here. Because see, 2 and 4 is divisible by 2. 3 is not divisible. All the three numbers should go in any one table. Okay. So we have to stop and our GCD will be 2 into 2 into 3 into 5. Okay. So when you multiply this, 2 2s are 4, 4 3s are 12, 12 5s are 60. Okay. So we can say here that therefore GCD of 120, 180 and 240 is 60. Okay, understood this? So here we have finished the second part. Now see, next is question number 5. We have to find the LCM. Okay, now we have to find the LCM of the following numbers, least common multiple. Okay, now of 11 and 16, the first question is 11 and 16. Now see, 11 and 16, 11 again is a prime number. Okay, 11 is a prime number and 16 is divisible by 2, it is divisible by 8. But what happens over here? See, 11 and 16, even if you see, I'll just show you. See this 11 and 16, 11 and 16. Okay, if you factorize it, this is only going to go 11 ones are 11, 16 we have to bring down in LCM. You can take 2 8s are 16, bring this one down. 2 4s are 8, bring this one down. 2 2s are 4 and then 2 1s are 2. So what we get here is we get 11 multiplied by 2 into 2 into 2 into 2. So 11 multiplied by 2 2s are 4, 4 2s are 8, 8 2s are 16. The same thing we are getting. Understood? So 11 multiplied by 16. We have to multiply these two numbers. Okay, we have to find the product of the two numbers when we have prime number over here. Okay, so when we have a prime number over here, what we will do? We will directly find the product of these two numbers. That will be our LCM. So see here for LCM of 16, 11 and 16. LCM of 11 and 16. Okay, LCM of 11 and 16 is 11 multiplied by 16. See here, 11 multiplied by 16, just multiply it. 11, 16 multiplied by 11. 1 6 are 6, 1 1s are 1, put a 0, again 6, 1, 6, 176. Okay, 176, because these two numbers are said to be co-prime numbers over here because their common factor is 1. Okay, so when we have to find the LCM, we have to multiply. When we have co-prime numbers, 11 is a prime number. It doesn't go in any table, so we have to directly multiply these two numbers and find the LCM. Understood this one? Now see the next one, 7 and 49. 7 and 49. 7 and 49 both are divisible by 7. 7 ones are 7. 7 sevens are 49. Again 7 we can take, 7 ones are 7 and bring this one down. So what are the two numbers left over here? Product of the two numbers, 7 multiplied by 7 is equal to 49. Okay, so therefore you can write, therefore LCM of 7 and 49 is 49. Understood the second sum? Now see the third one. 16, 48 and 6. All are even numbers. Okay, so see the last number, 6, 8, 6. That means we can start with 2. 2 8s are 16, 2 2s are 4 and 2 4s are 8. Okay, then 2 3s are 6. Again can we take 2? But all we cannot take. Yeah, we can take 2 because this is LCM. Okay, we can proceed. So we can again take 2. 2 4s are 8, 2 1s are 2, 2 2s are 4 and 3 you have to bring it down. Now see all the three numbers. Again we can take 2. 2 2s are 4, 2 6s are 12 and bring this 3 down. Again we will take 2. 2 1s are 2, 2 3s are 6 and bring this 3 down. Now 3 and 3 over here, that means we can take 3 times table. 3 1s are 3, 3 1s are 3 and bring this 1 down. Okay, so we got all the factors here. 2, so therefore 2 into 2 into 2 into 2, 4 times 2 multiplied by 3. Okay, so 2 2s are 4, 4 2s are 8, 8 2s are 16 and 16 3s are is 48. Okay, 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 3s are 48. Then you can write the final answer over here. Therefore LCM of 16, 48 and 6 is 48. Understood? So here we have finished question number 5. Now see question number 6. 6 we have already done this way type of sum in 5.3 in the practice at 5.3. The product of two numbers is 120. Okay, product of two numbers is given 120. If LCM is 60, then what is their GCD? I told you whenever they have given you product of two numbers, LCM is given and GCD is given, there is a formula for this. We will use solution. What you will do is first write whatever is given. Product of two numbers is given, right? Product of two numbers. So write product of two numbers. Product of two numbers is equal to 120. The product of the two numbers is given. LCM is 60. So write there LCM is equal to 60. GCD, what is their GCD? We don't know. So GCD is equal to question mark. Product of two numbers, GCD, LCM is given here. GCD we have to find, LCM is given. So there is a formula. What is the formula? Product of two numbers is equal to GCD multiplied by LCM. Okay, product of two numbers is equal to GCD multiplied by LCM. What is the product of two numbers given? 120. So write below it. Product of two numbers is 120. So just write below it 120. Is equal to is the next, put equal to sign. GCD is not given. Understood? So you can just write GCD as it is. Multiplied by LCM. LCM is given 60. So just below it you are going to write whatever is given. Now see 120. So 120 we will keep it over here only. 120 keep it over there only. Okay, again write it down, keep it over there only. Is equal to GCD. Is equal to GCD. Again write this part as it is. 120 is equal to GCD. Write it as it is. I told you last time also this number 60 is in multiplication. Okay, it will come here in division. Okay, so now that 60 we have to bring it down over here in division. It is in multiplication, it comes down here in division. 120 upon 60 means it is division. Upon means division. Now see how you can reduce 0 and 0. Understood here? 0 and 0 will get cancelled. Then 6 ones are 6, 6 twos are 12. Okay. If you don't know how to reduce, you can also do the division. 0 and 0 if you cut that 0 and 0, 12 is there and 6 is there. 6 twos are 12. So you get GCD is equal to 2. Understood? So what is their GCD? GCD is equal to GCD is equal to 2. Understood this sum? Now see the second sum of question number 6. The GCD of a number and 16 is 4 and the LCM is 48. What is that number? Okay, we have to find that number. Which number? I'll tell you. Now see here, see the question. The GCD of a number and 16 is 6. See the first sentence. The GCD of a number and 16. These are the two numbers given here. Of these two numbers, the GCD of one number, this is one number and this is another number. Okay, that means the product of two numbers is this, one number and another number. GCD is 16, GCD is 4. Okay, what is the GCD given? GCD is 4 and LCM is 48. Okay, understand the question. GCD is 4 and LCM is 48. Now understood? So first what I'm doing is I'm just writing that first. What is given, we will write that. GCD is 4, LCM is 48. Now see this, a number and another number. Now we know the formula. Product of the two numbers. Product means you multiply those two numbers. Product of the two numbers is equal to GCD into LCM. Understood? So product of the two numbers. Which are the two numbers? One number is given, another number is not given. So what is the question? What is that number? So from two numbers, from product of the two numbers, one number is given, the other one we have to find. Okay, so what we will write is, one number is 16. Okay, 16 is one number. Another number is not given. Another number we will put we will assume as X. Okay, now another number we will assume at X, or you can also just put a question mark. Okay, if you otherwise just put a question mark. For another number, put a question mark. Now you know the formula for this. What is the formula? Product of two numbers. Product of two numbers is equal to GCD multiplied by LCM. Okay, now which are the two numbers? Product of two numbers, one is given, one number is given 16, so that product means multiplication. Two numbers, one number is given, another number is not given, just write over there, another number is equal to, another number is not given, or you can also use X. We can also say over here in this place, let the another number be X. So instead of writing this, you can write 16 multiplied by X. Like that also you can do. So 16 multiplied by another number, you can write X. GCD is 4, LCM is 48. Understood till here? Now what we have to do is, we have to find another number. I'm doing it over here. See, I'm doing the rest of the sum over here. Another number, I will write again another number is equal to, now see, after another number what is given? 4 multiplied by 48, write it as it is. 16, I told you, whenever it is in multiplication, you have to bring it here down in division. So 16 here is in multiplication, will come down in division. Understood? First, okay, then what we will do here is, we can reduce this. I'll show you how to reduce it. See, 16 ones are 16, 16 threes are is 48. See here, 16 threes are, 3 6 are 18, 3 ones are 3 plus 1 4. 16 what? 16 threes are is 48. So 16 ones are 16, 16 threes are 48. Now what is left on top? There is a multiplication sign. So multiply this. 4 threes are 12. So another number we got 4 3s is 12. So what is the other number? What is that number? We can write the required number is, we can write the final answer. Therefore, the required number is 12. Understood? See, first what you do, the question looks a bit confusing, but what you do, see, you understand the question. GCD is 4. GCD is 4. LCM is 48. Now see here in between a number and 16. A number and 16. That means the two numbers, one number is given 16, but a number, that is the other number, is not given. Understood? A number and 16. That means 16 is given, one number is given, another number is not given. So first write whatever is given. GCD, LCM is given, one number is given, another number is not given, just put a question mark. Then use the formula. Product of two numbers is equal to GCD multiplied by LCM. Product of two numbers means we have to multiply those two numbers. Okay, 16 and another number. But at another number, what we have to find is not given. So 16 multiplied by another number is equal to GCD multiplied by LCM. Then next, another number, write, see, this part you have to write it as it is in the next step. Write this part as it is. And 16 will come here down in division. So understood the next step? Another number is equal to 4 multiplied by 48 as it is. And 16 will come down in division. Then I told you how to reduce it. 16 ones are 16, 16 threes are 48. So another number, what was remaining? What was the second number? 4 threes are is 12. So understood how we got 12 over here? So required, the other number is 12. The required number is 12. Understood? A carpenter has two wooden strips. The length of one strip is 54. Okay, two strips he has. One strip is 54 inches and the length of another strip is 72 inches. So two strips he has. One is 52, another one is 72. He wants to cut both the strips into equal length. He wants equal lengths of strips. Okay, so that no wooden strip is left over. When there is nothing left over means you should understand that this is a GCD word problem. And also, what is the maximum length of the strips that he can cut? Maximum. Again, maximum is given, means it is GCD. Understood? So what is the question? A carpenter has two strips. One is 54 and the other one is 72 inches. From that, he want to cut both strips into equal lengths. From that equal lengths he want to cut. Okay? And in such a way he wants to cut that so that no wooden strip is left over. What is the maximum length of the strips he can cut? Maximum GCD. No leftover, there is no leftover. No leftover, again GCD only it is. Understood? So what we will do is, we will first factorize these two numbers and find the greatest common factor, GCD. Now here you can also write length of one strip is 54 inches and another strip is 72 inches. Understood? Length of one strip is 54 inches and another strip is 72 inches. So now we have to first find out the GCD of these two numbers. So 54 and 72. We will find the GCD. Last number is 4. Last number is 2 here. Okay, that means we can take 2 times table. 2 2s are 4 in this. 2 2s are 4 in this. Carry 1. 2 7s are 14. 2 3s are 6 in this. Carry 1. 2 6s are 12. Can we again take 2? No, because 27 is not going in 2. Understood? So we cannot take 2. But we can take 3. 3 9s are 27. 3 1s are 3. 3 2s are 6. Again we can take 3. 3 3s are 9 and 3 4s are 12. See now 3 is a prime number, doesn't go in any table, so we have to stop over here. Understood? We have to stop this factorization. If it would be LCM, we would have continued, but it is GCD. Okay, maximum GCD, so we have to stop this. So what are the factors you get over here? 2 into 3 into 3. That means 2 3s are 6, 6 3s are 18. What was the question? What is the maximum length of the strip that he can cut? So what is the maximum length of the strips that he can cut? He can cut 18-inch strips. Understood? So therefore he can cut, or the carpenter can cut, therefore he can cut the strips of 18 inches. Don't forget to write the unit, inches. Understood? So therefore he can cut strips of 18 inches. Understood the third sum of question number 3? So understand, always understand, maximum is given, greatest is given, no leftover, nothing is left. That means it is GCD. And for LCM, whenever least is given, whenever least, minimum, maximum is GCD, minimum will be LCM, minimum, least, or even they say meet again at the same time. Okay, meet again at the same time, meet at the earliest, that will also be LCM. So this is how you understand the word problem. Okay, understood the third one? Now see the last problem. Sameep has 84 mangoes and 105 apples. He wants to place these fruits in boxes, okay, so that each box has the same number of fruits and each box contains only one type of fruit. Okay, now these 84 mangoes and 105 apples, he want to place these fruits in boxes. Okay, but so that each box has the same number, each box should have the same number, equal number of fruits. Understood? Each box should have equal number of fruits and each box contains only one type of fruit. Each box should have only one type of fruit, not mixed both apples and mangoes. Each one box should have only one type of fruit. Understood what is the question? Now see, there are two questions based for this. What is the maximum number of fruits he should put in a box? Maximum, I told you maximum. Whenever there is maximum, there is greatest. That means you have to find the GCD of those two numbers. Understood? Whenever maximum, greatest, nothing is left. Okay? Nothing is left is given in the word problem, or maximum or greatest is given. First we will find out the GCD. Okay? GCD of what? 84 and 105. To see the solution over here. Now first we will find out the GCD of 84 mangoes and 105 apples. So we can also start with a number of mangoes. Number of mangoes is 84 and apples is 105. Mangoes, number of mangoes is 84 and number of apples is 105. So we will first find out the GCD of mangoes and these two numbers, 84 and 105. So 84 and 105. Now see, the last number here is 4. This is divisible by 2, but both should be divisible by 2. The last number here is 5. That means we cannot take 2 times table. But these two numbers are divisible by 3. We can take 3 times table. 3 2s are 6 in this. Okay, 3 2s are 6. How much is remaining? 2. It becomes 24. 3 8s are 24. Again over here, 3 3s are 9. Okay, in 10, 3 3s are 9. 1 is left, so carry 1. That becomes 15. 3 5s are 15. What are the two numbers? Next two numbers, 28 and 35. 28 and 35, these two numbers are divisible by 7. Okay, so we will take 7 times table. 7 4s are 28 and 7 5s are 35. Can you proceed this factorization? No, you cannot proceed here because you have to stop. We have to find the maximum number of fruits. Maximum means GCD. So we have to stop over here. We cannot proceed. If it would be LCM, we could take 2 2s are 4. 5 is not going. 5 is a prime number, so we have to stop. So therefore what we get, GCD is equal to 3 multiplied by 7 is equal to 21. That means, see what was our question? What is the maximum, first question, we got the answer to the first question. What is the maximum number of fruits he should put in a box? Okay, what is the maximum number of fruits he should put in a box? So we'll write the final answer here. Answer: therefore the maximum number of fruits he should put in one box, in a box means in one box, in a box, is 21. Understood? So the maximum number of fruits he should put in one box is 21. We got the answer to one question. Now one more question is there, just understand that. How many boxes will he need to store the fruits? Now how many boxes he will need? Okay, how many boxes he will need? He will need, we will just find out that. Now see the rest of the sum, I will do it over here. The first question you all understood, the first one. See, the answer to the first question is over here. The maximum number of fruits he should put in one box is 21. Okay, now see what was the number of mangoes and the number of apples. So what we will do to find the second part, this is the second part of the same question. Okay, so what is given? Number of mangoes is 84. See here, number of mangoes is 84. Okay, number of mangoes is 84, and here I am writing number of apples. Number of apples is how much? 105. Number of mangoes is 84. Number of mangoes is 84 and number of apples is 105. Now what did we get? GCD we got 21. What was that? Maximum number of fruits he should put in one box, and in one box holds how many? 21 fruit. Okay, in one box he can put 21 fruit. So that means this 84 we are going to divide it by 21. Understood? Number of mangoes is 84 and one box is holding how many mangoes? 21. That means 84 we will divide it by 21. See, I am showing you the division here. 84 when we divide it by 21. We'll just check. 21 4s are 4 1s are 4, 4 2s are 8. Okay, 21 4s are is 84. So what we will take? 21 4s are 84. So when you divide, you get 4. Understood? One box is holding 21. What was the question? How many boxes will be needed? So to hold 84 mangoes, 4 boxes will be needed. Okay, so we will write here 4 boxes are needed for mangoes. Now same way we will find how many boxes are needed for the apples. So one box, again one box holds how much? 21. The same thing, one box is holding 21. See here, one box was holding 21, 84 divided by 21. Same way one box is holding 21 over here too. So 105 divided by 21. So that 105 we will divide it by 21. So 21, if you take 5, 21 5s are 5 1s are 5, 5 2s are 10. 21 5s are 105. 5s are 105. You get 0 over here. So when you divide this, you get 5. That means how many boxes will be needed to hold the apples? 5 boxes. Okay, so number of mangoes, for 84 mangoes he will need 4 boxes, and for 105 apples he will need 5 boxes. Now what is the question? How many, second question is how many boxes will he need? See the second question. How many boxes will he need to store the fruits? How many boxes means we need to find out the total number of boxes, right? So 4 boxes for mangoes and 5 boxes for apples. Okay, so therefore total boxes he will need is 4 boxes for mangoes and 5 boxes for apples. 4 plus 5 is 9. Understood? So how many, what was the question? How many boxes will he need to store the fruits? So answer, therefore he will need 9 boxes to store the fruits. Understood? Understood this sum? See, total number of boxes was 84. Sorry, total number of mangoes was 84 and total number of apples was 105. From that, one box we got, GCD we got 21. That means one box is holding how much? 21 mangoes, and same way 21 fruits. So 21 mangoes, 84 divided by 21. Same way 105 divided by 21. So for mangoes we need 4 boxes and apples we need 5 boxes. So 4 plus 5, when you add total boxes, he will need 9 boxes to store the fruits. So this sum, see this entire sum, this was the question. This was the question. And see, for the first part, what is the maximum number of fruits he should put in one box? See the solution to the first part, the maximum number of fruits he should put in one box. This is the solution to the first part. Okay, the maximum number of fruits is 21. Then the second part, you can see here, I have done it over here. See, the second part is over here. Okay, so how many boxes he will need? He will need 9 boxes to store the fruits. Understood? So here we have finished exercise 5. If you have still not subscribed to my channel, please do subscribe, and if you find this video helpful, please do like and share with your friends. Thank you for watching.